Hey everyone, it's Bradley Bush with another algebra video for you. Today we are talking about arithmetic sequences and specifically how you can define them recursively. And then we've got lots of examples. If this is the first time here to my channel, welcome. I'm thrilled that you're here. If you're returning, thanks for coming back. I really appreciate it. If you like what you see or if it's helpful, please give me a thumbs up, leave a comment, or subscribe to my channel. Let's get started. What is an arithmetic sequence? An arithmetic sequence is a sequence where each term after the first differs from the previous by the same amount. And we call that same amount the common difference of a sequence. So the first term of a sequence is whatever it happens to be. We have two examples here. The first example, the first term is 6. The second example, the first term is 13. But once they give you the first term, then really you just need that common difference because every term after that differs from the one before it by that common difference. So if we can see this from here. So 6 and 4, that's a difference of -2. 4 and 2, it's a difference of -2. 2 and 0, the difference of -2, and so on. 0 and -2, difference of -2, and so on. So everyone after that 6 is just the one previous minus 2. So we can see that the common, or the first term is 6, obviously, because we can just look at the sequence and tell that. But the common difference is -2. In the next example, the first term is 13, and they call that first term a sub 1. And the second term is a sub 2, the third term is a sub 3, and so on. But you can find the common difference just by taking the difference of two terms. So we can look at this and say, well, from 13 to 17, we have a difference of 4. From 17 to 21, we have again a difference of 4, and it will be the same. If it's an arithmetic sequence, it'll be the same regardless of which two terms you choose. I'm just pointing this out because you can see that they all are in fact the same. So 25 and 29, difference of 4. So the difference here, D, is 4 for the second example. If we needed to write the first 4 terms of these arithmetic sequences, we've got 3 options here and a space for term 1, term 2, term 3, and term 4. For A, we have the first term is 200. So I can just write that out. Term 1 is 200. Now, the difference is 20. So if I take 200 and I add 20, then the second term has got to be 220. And then again, if I'm adding 20 again, I would have 240. And if I add 20 again, then I get 260. So my terms then are, what color should I choose? It's so hard to choose colors. 200 is my first term, 220, 240, 260, and it keeps going, but we don't know what the other ones are. We're not finding them at the moment. So those are the first 4 terms. And again, this is a sub 1, a sub 2, a sub 3, a sub 4, and so on. Let's look at B. B, our first term, is 300. So we can go ahead and write that, 300. Our next term will differ from 300 by 90, so we subtract 90, which gives us 210. If we then subtract 90 again, we get 120. If we subtract 90 again, we get 30. So our first 4 terms then for this arithmetic sequence would be 300. A1, A2 is 210, A3 is 120, and A4 is 30. And again, there are more of them, but we're not finding them. Our third example here, C, problem C, our A1, our first term, is given to us as usual, and that is 5/2. And our difference, our common difference, is a -2. So if I took a half away, what is a half? If I have 5 halves and I subtract 1 half, what do I get? 4 halves, which is 2. And then if I subtract again 1 half, I have 4 halves minus 1 half, which gives me 3 halves. And then I have 3 halves, and I subtract 1 half again, gives me 2 halves, or 1. So our first four terms are 5 halves, 2, 3 halves, and 1. And that's it. So we kind of noticed a pattern in those last problems. It was each term, we would just add or subtract that common difference from the previous term. And that's how we would keep going. And it was a very recursive way of finding the next term. And we can formally state that as this general definition of the nth term. So a sub n, which is any given term, you can find any given term just by taking the previous term, a sub n minus 1, and then adding that common difference. If that common difference is negative, then you're subtracting it. So we just need a sub 1, which is the first term, and then the common difference again, and we can use this formula, and we formally have a way of finding all of the terms. So let's write the first 4 terms of each of these arithmetic sequences. And we're given a sub 1, and we're given the general recursive formula. So let's start. A sub 1 here is 9. -9, that would be. And my a sub 2, so a sub 1. How about I say a sub 1 here? A sub 1 is -9. A sub 2, according to our, it kind of looks like a 9 right there. A sub 2, according to our recursive formula, is a sub 1 plus 6. A sub 1, we said, was -9. So we'll put a -9 for a sub 1. And then we add 6. What is -9 plus 6? -3. So that's a sub 2. We have a sub 1. What is a sub 3? A sub 2, the one previous, plus 6. A sub 2 is -3. And we are adding 6. So that gives us +3. And finally, a sub 4, we use a sub 3, and again we add 6. A sub 3 was 3, and we add 6, and that gives us 9. So our first 4 terms are -9, -3, +3, and then +9. And they keep going, but we won't find those. Let's look at exercise B. Our first term, a sub 1, is 50. So we'll write that down. A sub 2 is a sub 1 minus 20. That's the recursive formula that we're given. So a sub 1 was 50, and we have minus 20. That gives us 30. So we found a sub 2. A sub 3 gives us a sub 2 minus 20. And a sub 2 is 30. Minus 20 gives us 10. Great, we have one more. So a sub 4 is a sub 3 minus 20. And a sub 3 was 10 minus 20, which gives us negative 10. So the first 4 terms of this arithmetic sequence are 50, 30, 10, and then negative 10. And again, there are more of them, an infinite number, but we're only finding the first 4. Our final exercise number 3, C. A sub 1 is given to us as 1.6. A sub 2, again, is a sub 1 minus 0.4. So it's a sub 1 is 1.6. We subtract 0.4, and we get 1.2. So we have a sub 2. And now a sub 3 is a sub 2 minus 0.4. A sub 2 again was 1.2. And we subtract 0.4, and we get 0.8. And then finally a sub 4, which is a sub 3 minus 0.4. And that gives us a sub 3 is 0.8 minus 0.4, which gives us 0.4. So our first 4 terms there are 1.6, 0.8, whoops, I forgot one, 1.2, 0.8, and 0.4. And they keep going, but we're just finding the first 4. So there's an intro to arithmetic sequences defined recursively. Hope you enjoyed it. Thanks for watching. Have a great day.